Here's a thought experiment that instantly reveals what the modern world truly depends on. If you could snap your fingers and remove every ounce of gold from the world, markets would panic, headlines would scream, but the lights would still turn on. Now try the same experiment with silver. Not the silver in coins, not the silver in jewelry. I mean, the silver hidden inside contact points. The microscopic surfaces where electricity actually transfers. Remove that, and modern systems don't just get inconvenient, they get unreliable, fragile, expensive. Power equipment runs hotter, connections fail sooner, efficiency collapses. And here's the uncomfortable truth. The world's demand for silver is rising, while the supply chain that produces it can't scale quickly, even when prices jump. This isn't a story about treasure. It's a story about a metal quietly holding up the modern world and the bottleneck we built into our future. To understand the crisis, you have to start with the physics. Because this isn't hype, it's properties. To understand why the world keeps choosing silver, you have to zoom in. On the periodic table, silver isn't rare magic. It's something more useful. Among metals, silver is the best electrical conductor. That means it offers exceptionally low resistance to current flow. And it's one of the best thermal conductors too. That matters because modern electronics don't just carry electricity. They fight heat. Heat raises resistance. Resistance wastes energy. Waste becomes failure. So when engineers are designing systems that must be small, fast, and reliable, silver is often the cleanest answer. Not because it's precious, because it performs. And that performance shows up in the places that actually decide whether a system works or slowly breaks. If you think silver is something you can see, you've already missed where the real story happens. Most people imagine silver as a visible object, but modern silver is usually invisible. A thin plating on a connector, a contact surface inside a relay, a microscopic layer in a switch, a trace in a high reliability circuit. It's not there in big chunks. It's there in the exact spots where physics is unforgiving. And that's why silver appears in the ordinary things you touch every day, and also in the critical infrastructure you never think about. But here's what changed. The biggest pressure on silver isn't fashion. It isn't tradition. It's energy. Because the 21st century is rewriting how the world powers itself. This is where silver stops being a metal story and becomes an energy story. In the 20th century, the world ran on oil. Energy was something you burned. In the 21st century, energy is increasingly something you manage. Electrons moving through devices, grids, batteries, and power electronics. And that transition multiplies the number of control points in the world. Switches, relays, inverters, connectors, protection equipment. Now consider solar. A panel looks like glass and silicon. But inside, you need conductive paths to collect and move current efficiently. Different designs use different amounts. But across solar hardware, you're often talking about tens of grams of silver per panel, even as manufacturers work to reduce it. Then consider electric vehicles and charging. EVs add high current switching, power conversion, dense electronics, sensors, and charging interfaces. Reliability matters, because failure isn't just annoying, it's dangerous. So electrification doesn't just increase energy, it increases the number of places where energy must be controlled safely. And this begs the obvious question. If copper is so common and so cheap, why can't we simply use copper everywhere? Here's the part most people get wrong. Conductivity in a textbook is not the same as performance in the real world. When people hear conductivity, they imagine a simple wire. But modern systems don't fail in the middle of perfect copper. They fail at interfaces, where two surfaces meet, where vibration loosens connections, where oxidation and heat turn clean flow into loss. That's the difference between bulk conductivity and contact performance. Copper is an excellent conductor in a wire. But at a stressed contact point, it can degrade, heat up, and lose efficiency. Silver is used because it keeps those interfaces stable. It carries current with minimal loss, handles heat, and performs predictably under repeated switching. And once you start electrifying everything, cars, chargers, grids, you don't just need electricity. You need electricity that stays controlled, safe, and reliable. At millions of contact points, every day, for years. Which is why silver isn't a luxury material in these systems. It's a reliability material. And here's why this matters. Silver doesn't fail quietly. When contacts fail, problems cascade. This reliability is critical because the environment inside a switch is violent. Every time a circuit opens or closes, it creates stress. Heat, arcing, corrosion, microscopic pitting. At high currents, a tiny imperfection becomes a hot spot. A hot spot becomes damage. Damage becomes failure. And failures here don't stay local. One weak contact can trigger heat, shutdowns, and protection trips. In complex systems, a small fault can ripple outward. So engineers plate critical contact surfaces with silver. Silver survives the violence of connection again and again. It's the metal you never notice until something stops working. And as the world adds more electrified systems, it adds more contact points. Now watch what happens when an industry tries to use less silver, while the world demands more of it. This is where the story turns into a race, because solar is both the solution and the pressure. Solar manufacturers understand one thing perfectly: silver is expensive. So for years, the industry has been pushing thrifting, using less silver per cell through finer printing, better designs, and process improvements. And that works, to a point. But here's the paradox. Even if each panel uses less silver today than it did years ago, the world is installing so many panels that total silver demand can still rise. So the industry runs faster just to stay in the same place. Solar doesn't just consume silver, it competes for it. And competition only matters when a resource is constrained. So where does the constraint actually come from? Not demand, supply. Here's the twist. Most silver isn't mined for silver. Most people assume there are silver mines everywhere, waiting to ramp up. The reality is stranger. A large share of global silver production comes as a byproduct, tied to mining for copper, lead, zinc, and gold. Meaning the supply of silver is not controlled by silver demand alone. It's linked to the economics of other metals. So even if silver prices rise, supply doesn't necessarily surge, because the mines producing the most silver may be making their decisions based on something else. This is why silver can enter multi-year deficits. Demand rises structurally, while supply responds slowly. And when that happens, inventories get drawn down. That's the quiet mechanism behind the silver story people feel in headlines. Not a sudden disappearance, but a system that struggles to keep up. Which leads to the next argument skeptics always make. Fine, just recycle it. If recycling were easy, this entire problem would vanish. So why doesn't it? Recycling works best when a metal is concentrated and easy to separate. But modern silver is the opposite. It's dispersed across billions of products. Thin films, tiny contacts, microscopic plating mixed into complex assemblies. Recovering it is possible, but often it's not economically attractive at scale. Because collecting, separating, and processing dispersed silver can cost more than the silver itself. So a lot of silver doesn't return to the system. It slowly leaks out into low-grade waste streams, shredded electronics, landfills, and forgotten devices. And that's the core tension. Silver is essential in tiny amounts, but those tiny amounts add up to a massive industrial appetite. The internet loves one answer: just use copper. That answer is wrong most of the time. So could we replace silver? In some places, yes. Engineers can reduce usage, redesign contacts, or swap materials in low-stress applications. But substitution is never a single decision. It's a trade-off across heat, corrosion behavior, manufacturing constraints, and what failure would cost in the real world. A cheaper conductor that degrades faster isn't cheaper. It's a maintenance bill, a downtime risk, and a safety problem. That's why the future probably isn't silver disappears. It's silver becomes more strategic, used less per unit where designs allow it, and protected fiercely where performance is non-negotiable. And that's what makes this story bigger than a commodity chart. Silver sits at the intersection of physics, industrial scale, and reliability. If you want to understand the modern world, don't follow the headlines. Follow the materials. Silver isn't just a commodity, it's a signal. It tells you where modern civilization is under the most pressure. Energy, electrification, connectivity, control systems. And it reveals a hard truth about the future. We are building a world that depends on performance materials. Materials chosen not because they're glamorous, but because they make systems efficient, safe, and reliable. So the next time you hear the word silver, don't picture a ring. Don't picture a coin. Picture the contact point. The tiny surface where the modern world either works or starts to fail. That is the real cost of power. If you want more small things with big reasons, subscribe.